Okay, so basically, we're going to talk about the solution of this question. You got nine pillars, and you start on the first pillar, and you can only go up, right? When you hit a stick, you change pillars to the other pillar, yeah, and you keep going up. The question is, if you have sticks such that something starting from one ends up at the top of nine, okay? There's only finitely many sticks, okay?
Yeah.
Can you always remove a stick such that it ends up at the top of five,
Yeah.
okay? So if your answer is yes, then you have, no matter how you start, it has to satisfy the first condition. There is a stick you can remove
Yeah.
so that it does that. If your answer is no, you have to come up with an example where no matter which stick you remove, you can't end up at the top of five.
Yeah.
All right?
I think I almost found it.
Okay, so this has a very nice answer, okay? And um actually the idea behind this answer is the same as the idea behind that Santa Claus question where they sent the presents.
Bob.
Okay?
And the conveyor belt, not Santa.
Yeah, yeah. So so I'm basically showing you, I guess, Rayden's solution, yeah? This is the one Rayden came up with, but with obviously some modifications so you can understand what's going on. So what's really nice is instead of having one beetle start at one, you can imagine a beetle start at every pillar. Okay? Does that make sense? So you imagine nine beetles. Okay? Right? And you imagine nine beetles starting at the. You're not even listening to me.
Guys, listen to the solution now. You guys lost your time to try this
So
unfortunately.
you have nine beetles, and they're all going up at the same time. Okay? And if there's a horizontal stick at that point, okay? So the sticks. Wait. So the sticks can't have the same height. Is there a condition? No two of which being at the same height. Okay. Well, that saves us. So no two are the same height, so they can't. They can only. All nine of them can ever only reach one stick at a time. Yeah? Yeah? And what happens when all nine of them reach a stick? These two just swap. Yeah? Does that make sense? So what you get is you get nine beetles still at the other end, but possibly in a different order. Okay? So that's called a permutation.
Yeah.
Does that make sense?
Yeah.
Definitely.
Huh?
Literally?
What?
Yeah, yes, definitely. I definitely know what a permutation is.
I just told you what a permutation is.
Yeah.
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 Okay, so that you have the same nine beetles, but in another order.
Yeah.
Yeah.
Wait, 9
So no two beetles, no two starting pillars can end up at the same destination, and every destination can be reached by something.
Yeah.
Does that make sense? I think that's a really nice way to understand what's happening. Okay. So actually, that's the same as the Santa Claus question. You imagine presents going from all of the different conveyor belts.
Yeah.
Okay. Anyway, so and obviously you can prove that very simply because whenever they reach one, this one goes here and the other one goes there. So the total number of beetles is equal off in and out. Yeah.
Yeah.
Okay. So that means that there is some starting point which ends up at 5, right? So there's something, and that something is not 1, right? Yes? Okay, so we're going to prove the answer is yes, you can always remove a pillar. So
a stick, not a pillar.
a stick, yeah? So there's something starting at 1, okay? And that ends up at 9, right? And then there's something ending at 5, and it started from something that wasn't 1, right? Okay. So this is probably the sussest part of the argument, but it's actually really believable. Is it has to intersect the red path. The blue path has to intersect the red path. Okay? That makes sense?
Yeah.
Because the 1 to the 9 cuts it in half, and this is going from one half to the other half. So it has to cross somewhere. Yeah?
Oh, yeah.
That makes sense?
Yes.
There's someone at the door.
Someone
Push the wind. That's just a win.
There's someone at the door.
Oh,
Okay.
I know.
So it has to cross at some point, right? Okay. Okay, so when it crosses, it can cross the first time it meets. The first overlap can happen on a vertical segment or a horizontal segment, right? Does that make sense?
Yeah.
Okay, so it can be like this, yeah, or it can be like this, yeah, like an overlap, yeah. Okay. Can you see what happens if it overlaps on a vertical segment? Can you?
They can't.
Why?
Because when one goes to the other side and the other one goes to that side, then they overlap on the horizontal, but then they can never be on the same line moving upwards.
Because then they'll end up at the same spot, right? Well, I should have spoiled that crap.
No, you just.
Ah. Damn it.
Hooray.
Wait, were you thinking that?
No.
Ah.
Do you
I had too
understand
much
it now?
confidence in you.
Do you understand it now? Though?
Yeah.
The problem is if that first intersection is on the vertical, then the path that they take after that vertical is the same, right?
Yeah.
Then that means one wouldn't end up at 9. It would end up at the same path as
So therefore, the horizontal one. I mean, only the horizontal one is.
Yeah. So they have to intersect at a horizontal one, right? So what does that mean? It means it does something like this, right? This one's coming down, and then it's going down like this. Or you can think of it as going up from here and then going up to 5. Yeah, or it doesn't have to end up at 5. It doesn't have to go 5 right away, but... Okay. And then the other one is coming from this way and going there, right? That makes sense? Those are the only ways it can go from a horizontal, up or down, okay? And it has to be one up and one down, okay? So this way, if it goes this way, they're not even listening to me. If it goes this way,
Yeah.
right, then what happens is if you remove this horizontal stick,
Yeah.
right,
Yeah.
then the fates of the beetles will be switched.
Yeah.
Yeah?
Oh.
Does that make sense?
Yeah.
So the red one now is going to go
To the yeah.
along the blue line. Yeah?
And then the blue
And the-
goes to the red line.
On the blue, I don't know what the blue.
The blue
Yeah.
goes to heaven.
Alright. You see?
Yeah. It goes to
And then it ends up in 5. So there always is a stick you can remove, it ends up in 5. Okay?
Yeah.
Yeah.
What about this one?
Yeah. So some people came up with lots of examples
This one.
where one of the sticks, you just remove it and it goes up to 5.
What about this one?
Your example? Okay. Is there any questions about that?
Can you solve this one?
That's pretty cool, right? Yeah?
Yeah.
That's pretty nice, right?
Yeah.
I mean, okay, there's other solutions which aren't as nice. So if you look at Liam's solution, it's like so horrible, okay?
well.
And it's not even a proof. So it's like, so you take a path, so you imagine a beetle coming down from 5,
What?
right? And you take the first intersection, so it's just coming down naturally, right?
From what?
From 5,
from
top of 5.
From 5, yeah.
So it's undoing something.
Uh-huh.
And then you delete the first intersection it has
With that.
with the red path. Yeah. And then he claims that that will end up going back to 1.
I mean, it's not
Just
wrong.
keeps adding one.
It's not wrong. But, like,
It's just not a complete proof.
it's just not.
Yeah.
I guess the sausage, when mocking this, the sausage part is the thing that they will definitely say.
Yeah.
Maybe you could do like a pseudo IVT argument. The only problem is like you can't really define a function very you can like go like through each stick multiple times. Like the function
Yeah.
would be well defined, I guess. You know what I mean?
Yeah.
So like yeah, making an IVT out of this is a bit annoying.
Mm. Yeah. Yeah, but I guess it's nice because it's super believable in the high school.
Yeah, but
And that's how they prove IBT in high school anyway, right? That's the proof, you know? Yeah, I get a discrete IBT.
yeah, maybe you could say like it splits, like that one splits into two regions, and then like if you need a continuous bar from like region A to region B, it must pass like it must pass through that like border or something. I don't know.
Yeah.
I think I deproved it.
Alright. Alright.